Welcome to part 4, I think. We're on number 13. It asks us to approximate the area under the curve of y equals x squared over the interval 0, 5 by dividing the interval into 5 subintervals and using a Riemann sum. Draw a picture first. So bossy. Okay. So let me draw the interval. I want to make this picture kind of not too tall, so 1, 2, 3, 4, 5. I'm doing x squared, so 5 squared is 25. So I'm going to do 5, 10, 15, 20, 25. Okay, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And 5 squared is 25. So here's my function. I'm not so great at drawing on this thing. Shouldn't go below the axis there, it should just go down to it, nice and even. Okay, so here's x squared. We want to divide it into 5 subintervals, and it's 0 to 5, so this is our first guy. This is my second guy, third guy, fourth guy, and 5 guy. No problem. Okay. So we want to do these Riemann sums. Is the one where you draw these boxes. Okay, this box is just flat. Each box we give it the height of the guy on the left. So that's my second box. Here's my third box. Here's my fourth box. And here's my fifth box. Okay, all I need to do is sum up the area of these boxes. So I'm going to write this in a big bracket because you don't really need to write this. I want to calculate the area, which is about equal to the sum. We have 5 guys. For each guy we're taking f of the guy on the left. So my x1 equals 0, my x1 is 1, my x2 is, got to increment here. My x sub 2 is 1. My x sub 3 is 2. My x sub 4 is 3. My x sub 5 is 4. Okay, so those are what I'm doing for these xi's. Times delta x. Delta x is the width. And in this case it equals 1 for each of these boxes. Okay, but really I'm just doing areas. Okay? So for my first box, this one over here, the height is 0. The f of x1 is 0. So that is f of x1. And my width is 1. For my second box, the height here is f of 1, which is 1. And the width is 1. This one here is f of x2. x3, my height is, it's 2, so my height is 4. My width is 1. For the fourth box, my height is 9. My width is still 1. And for the last box, my height is 16, and my width is still 1. So I have 0 plus 1 plus 4 plus 9 plus 16, which is 30. This is not an extremely accurate estimate of this integral, but it's showing that you know what a Riemann sum is. Okay, next page. Definite integrals, good. It's really important that you give me exact answers and that you show all of the work. I say this because it's not very hard to calculate these with your calculator. I don't care what the result is in your calculator. I want to see you work it out by hand, so write all the steps, even the ones that you don't actually need yourself. Okay, so all we do here is we write the antiderivative, in this case 3x. We don't have a plus c here because we're going to plug in numbers. And then we take that from 2 to negative 1. So first we plug in the 2, we subtract, and we plug in the negative 1. That's what this notation means. Sometimes people write it like this with a tall bracket. I'm fine either way. I do want to see this step where you plug it in. You don't have to write any more steps after that besides the answer, because if you type this in your calculator, it's fine. But I'm going to write my steps because I need to. So the answer to that is 9. So let me just be clear. What I need to see is, I need to see this step, I need to see this step, and I need to see this step. Okay. Next problem. 1/2 x plus 7 from 2 to 0. Okay. This is x squared. We need to divide by 2, so that gives me 1/4 when I multiply it by this 1/2. Plus 7x. And we're taking it all from 2 to 0. So first I want to plug in 2. 1/4 times 2 squared plus 7 times 2 minus, look, if I plug in 0 to both of these guys, I'm just going to get 0, so I'm just going to put the 0 there. 1/4 times 2 squared is 1 plus 14. Oops. That gives me an answer of 15. Okay, square root of u. Remember, square root is the same as u to the 1/2. So we add 1, we get u to the 3/2, and we divide by 3/2, which is the same as multiplying by 2/3. Then we're taking that from 8 to 0. We're really going from 0 to 8. I keep reading the numbers backwards, but we plug the 8 in first. So 2/3 times 8 to the 3/2. When we plug in 0, we're just going to get 0, so I'm just going to leave this like this. This is perfectly precise. 8 to the 3/2 isn't any kind of nice number, so there's no simplifying that makes sense here. Okay, 2 over t. That's going to give me 2 natural log of t. We're going from 2 to 5. So we plug in the 5 first, 2 natural log of 5. Minus 2 natural log of 2. Perfectly happy with that answer. Okay, next page. Last integral, e to the 3x minus x cubed from 0 to 1. So my antiderivative, e to the 3x times 1/3 minus 1/4 x to the 4th. From 0 to 1. So first we plug in the 1. We get 1/3 e cubed minus 1/4 times 1, which is 1, minus 1/3 e to the 0 minus 1/4 0 to the 4th. So this gives me 1/3 e cubed minus 1/4 minus e to the 0 is 1, so minus 1/3. So that is 1/3 e cubed minus 7/12. Perfectly precise number. Okay, Sally Sweets finds that the marginal revenue, marginal always means you're going to have a derivative, is given by this formula, and they even wrote it saying it's a derivative of something. We want the total revenue for 200 pounds. So we're basically, I said to think of an integral as like a kind of sum. We're really summing up all these tiny marginal revenues as we start with selling 0 pounds or go up to 200 pounds. And my function is 6x to the negative 1/6. Okay, now I've turned it into an integral. It's no big deal. I have x to the 1/6 plus 1 is 5/6. There's a 6 in front, and then I need to multiply by 6 over 5 to finish taking the derivative. Integrating. Okay, and we're going from 0 to 200. So I need 36 fifths times 200 to the 5/6. When I plug in 0, I'm going to get 0, so that's my answer. I'm okay with that, but since this is a business problem, I'm also okay if you put a decimal approximation in here, as long as you show your work. And my calculator tells me this is approximately $595.47. All right, number 16. ProArt Inc. determines that its weekly online sales in hundreds of dollars 2 weeks after online sales began can be estimated by S of t equals 9e to the t. We want the average, not total, average weekly sales for the first 5 weeks after online sales began. Okay, whenever you want an average of some function, so here's my function, 9e to the t. So it's going to be an exponential function that starts at 9. And we want to go to 5. So I have this area, but I want to know the average height. So it's always given by 1 over, and then we want the width of this interval is 5. Integral from 0 to 5 of 9e to the t. So this is 1/5 times, so the integral of 9e to the t is just going to be 9e to the t, no problem. Yay. From 0 to 5. So that's 1/5 times 9e to the 5th minus, taking the 0, 9e to the 0. E to the 0 is 1, so 9e to the 5th minus 9. So I'm okay with that answer. It's perfectly precise, but this is a business problem, so let's figure out what it is in decimals, approximately. I get approximately 265.34.